a very special Friday forum and episode of TheSquare. I'm joined by Blake Arnold, who is the the shop fabricator in the model shop. Thanks for being here, Blake.
Happy to be here.
We're going to do something a little bit different today. We are going to be doing a live Q&A with Manuel Jiménez, who's in Spain. He's a designer and the co-founder of Nagami. So we filmed an episode with Manuel several weeks ago, and that'll be available as a complete episode in the future. But for this afternoon, we cut it all down to about 13 minutes so you can get some background on what our topic is, and then we'll follow this with a live Q&A session with Manuel in just 15 minutes. The QR code will be live, so as you're watching this episode, if you want to start putting in questions, feel free. Now, before we jump into the episode, a word of warning. I was on jury duty, so Adam Flaw jumped in to host, and Blake was busy doing the actual work of the model shop.
That's right.
So Dylan filled in for Blake, which shout out to Dylan, congratulations on the new baby boy. But you're going to get a little of the B team until you come back up here with us live to have that live Q&A with Manuel. So without further ado, here is our episode.
Good day and welcome to today's episode of TheSquare. I am not Brandon Carmichael. My name is Adam Flaw. This handsome devil next to me is Dylan Wells, and joining us all the way from Ávila, Spain is Manuel Jiménez García with Nagami to talk all things 3D printing. So here we go. Well, welcome, Manuel. I hope you're doing well today.
Yeah. Hello, how are you?
Doing good, doing good. Mm-hmm. I'm just going to jump right in here, and I'm going to start with, tell us who you are, how you knew you wanted to become an architect, your career path, and how that led to the formation or the creation of Nagami.
Okay, that's compressing 25 years in 5 minutes. Okay, starting from the beginning, I didn't really know I wanted to become an architect. I wanted to be a doctor, and then things went to a different path, and started to realize that I was very good at that, understanding how things were coming together. And I like buildings, I like design, I like graphic design, I like furniture, and in the end, I just decided for architecture. But I've always been a bit of a nerd, so I'm very passionate about technology since I was a kid. So the more I got into architecture, the more I thought that it would be good to start introducing the digital world more deeply into architecture. So from kind of like second year at uni, I started learning 3D modeling software and rendering and so on. Like back in those days, that was more used in animation, movies, and so on. So then I decided to go way deeper into that and move to London after I graduated from Madrid to study a master's in computational architecture, digital architecture at the AA, the Architectural Association. So there, I thought that digital architecture was belonging much more to whatever you see in the screen, right? But back in 2009, when I was studying, we started to see some examples of machines that can be tweaked to deposit material, to CNC material. I started to get like my first kind of connections with 3D printing, very small 3D printing, right? That was what was available. And then a few years later, after I graduated, I started running a research lab at the Barnet School of Architecture. So then I thought, well, rather than doing it as a university research, let's take the risk. Convince my brother and a very good friend of mine, who's now my third partner in the company, get a second-hand robot, put it in my hometown back in Spain, spend 2 years of our life designing a tool that could actually extrude plastic, right? Like, so 3 architects really working on a technology that we were really not related to, and creating a code that would allow us to materialize a design from the computer to the physical reality using our tech and an industrial robot.
So when it comes to Nagami, tell us a little bit about the company and what you do specifically there.
Well, so Nagami is actually mainly a design brand, but that specifically works with recycled plastics in large scale 3D printing, right? So we have industrial robots. Right now we have 7, and we're actually looking at extending it with another 25 in a few months from now, which is exciting. And so what we do is we take recycled plastic, we mix it with colorants, we treat it right. We get it through the extruder that we develop, so it gets heat up, right? And then gets deposited layer by layer or even printed in the air, right? And to make that possible, we developed different parts of or pieces of software, right? That allow us to communicate very smoothly with our machines, right? With our extruder, and also let us simulate and evaluate the designs that we do, so that they are 3D printable, right? Like they can actually appear in real life, not through our tech. So we developed a very smooth workflow between the design we do, which sometimes also happens in collaboration with other designers, the software that kind of rationalizes it and makes sure this can really come to life, and the hardware which makes it a reality.
Can you talk to what your experimental process looks like, not only at Nagami, but before, when you were testing a lot of things, at a university level? What does it look like to be kind of pioneering something that there really aren't a lot of precedents for, and figuring out, a lot of workarounds, and how do we actually make that into a production workflow, those kind of things, just the difficulty of going on something that's a somewhat new endeavor, and how much experimentation, trial and error needs to feed into that process.
Sometimes we believe that within the range of possibilities that we know we can manage, sometimes even for one thing or another, it fails, right? And you get material dropping, and then you need to start again, and you need to evaluate it, right? When we started the very first project we did, which was this Pompidou chair called the Voxel chair, because we were very concerned with the printing time, and one of the most frustrated things in 3D printing is that perhaps you are actually printing an object for 20 hours, and at the very end it fails, and then you want to cry. So because I cried so many times with traditional, like smaller 3D printers, right? Like after 10 hours, it's like, okay, this is just completely useless. We designed a system that was based on prototyping just one single line fragment, right? And then the object will be based on that same line fragment, repeated all over, right? And even if this is a very specific project, this is conceptually incredibly interesting for the world of 3D printing. After that project, if we want to really create furniture or create interiors or facades or even architecture, and we want to sell it, right? You can't spend months and months and months at failing prints and prototyping, right? So we always kind of think about the prototyping phase, what it's going to take, and how we can streamline it so that we guarantee a good result when it goes into production.
Do you still have like smaller desktop printers or things like that you print test ideas quickly at scale to test out, almost like mini prototypes in the process?
We don't use smaller 3D printers. First of all, because even if you can tweak a 3D printer, and we've done it to print thicker so that it's more or less equivalent to a scaled down version of the real object. The parameters, the way the material behaves is completely different. But also because with our technology, with our robotics 3D printing technology, we will print much faster, right? So it is actually the real object, but it's also way faster, to the point that 3D printing a small model like this big of a chair takes around 8 to 10 hours in a desktop 3D printer, and we print the real chair with our robots in 3 to 4 hours. Right? So it's for us actually a much more efficient method to not print scale models, but just print parts of what the real object will be like. Also, I think it's important to mention there when you because we do collaborate with very good designers, but we're very selective there, right? So we receive lots of requests sending us a 3D file, like an OBJ or an STL, saying, "Hey, can you print that?" It's like, well, we are not a 3D printing service. Also, because most of those OBJs that we receive are actually impossible to materialize. So yes, you have much more freedom, but you still need to deal with gravity. And that makes many of the shapes that we receive impossible. Right? The way we work with others is always having a very fluent communication from the beginning. We love working with designers that understand the technology. That's why we launched the company with Ross Lovegrove, Zaha Hadid, Daniel Widrick, designers that are really embedded in the world of the digital, right? That understand what we can materialize smoothly and how to push that a little bit farther, right? And through those conversations that we have with designers who are flexible enough to adapt our technology to their shapes, right? That's where the object becomes real in such a magical way, right? So summarizing that, to work with someone, we need to make sure that someone is as flexible as we are adapting, our technology to fulfill a specific design. They need to also adapt their design to work with our technology smoothly.
Is there anything with this audience in mind that you would just kind of leave them with or charge them with? Is it like just 3D print more, or is there other things that you'd like to say?
Definitely 3D print more. That's the first thing I would say. No, I would just say that I think we need to enjoy this moment. I think it's an incredibly fascinating moment for design and architecture. The boundaries between design and manufacturing, or between the architect and the contractor, start to blend, right? New opportunities for incredibly novel design techniques are to emerge, right? And that is incredible, and it's only gonna get better. So I would say, for an architect, for a designer, for anyone working in this discipline, just stay curious and creative, and push for your ideas to become a reality. And if no one wants to do it for you, then do it yourself. Right? Because then others will want to follow that path or to accompany you on that journey. And that is, for me, incredibly beautiful for our profession.
I think there's another 10 to 12 hours worth of material here if we do a real deep dive. So thank you for your time, Manuel. This has been fascinating, and we're going to look forward to a live session coming up next with questions from the audience.
Thank you so much. It's been a real pleasure. Looking forward to that session.
All right. Well, Manuel, thank you so much for being here. I know it's like got to be getting close to midnight here shortly. So I appreciate you joining on so late. And Blake, you want to start off with the first question?
You mentioned briefly at the beginning of the interview that you originally wanted to be a doctor. Could you share why?
Well, first of all, because I always wanted to do something meaningful, like help in a certain manner to like something, right? And this one was obvious, right? But also I felt very, very curious to understand how the human body was built. So then I realized I was actually meant to be an architect and not a doctor, right? Yes. So I like knowing how organs and are put together and they actually function in harmony. So then I thought it was better to then create my own harmony somehow through design. Lucky enough, it's very good for the world that I didn't become a doctor because I'm very nervous, so I would probably kill someone while operating. So good decision in the end.
So what is the durability of the materials in exterior uses? I've seen people printing with concrete and other things, but with thinking about materials outside of just concrete, what's the durability?
Well, plastic is with us forever for a reason, right? It's actually a very durable material, incredibly durable. It never disappears. So, there are different kind of plastics. If you work with PLA, PLA is biodegradable, so it can actually degrade. Well, that's why we don't use it. We use recycled PETG mainly. We've got the furniture outdoors in very hot weathers for the last 5 years, and they are still intact, right? We worked on facades and so on, and yeah, durability is not a problem. For architectural uses, the most important constraint I think is fire, right? So for obvious reasons, and there are different ways to deal with it. So one is through coating, but there's also polymers that are already fire resistant, like the one we just used for Caixa Forum in Valencia. So yeah, the world of plastics is actually incredible. I only know a little bit of it, and I work with a material every day. But I think through the evolution of plastic and especially recycled plastic through chemistry, we will get a very successful results for its application in construction. Actually, we can already do it, but as I said, through coating in most cases. But I do think that there will be much more plastics that are much more suitable to construction coming up in the very near future.
You mentioned using recycled plastic. What is the raw form of the material that your large-scale printers use? Is it standard rolled filament, or do you use the chips from recycled plastic or pellets, or what do you use?
Yeah, so we use pellets, and that was actually one of the challenges when we started the company. There was no 3D printer using pellets yet, right? There were pellet extruders, but they work horizontally, and just by putting it vertically, that is what you need to attach it to a robot. Everything changes. So we develop a pellet extruder also because the filament is already processed, right? So the material in a filament form is 5 to 10 times more expensive than pellets. Therefore, the material cost will be so high that then the price tag of the objects we produce would make them unaffordable. And we really wanted to bring 3D printing to the average design lovers and not just high-end collectionist. So that's why we went to pellets. We have done some research on printing with flakes. That's the previous step from pellets, right? Like when the material gets collected and then classified and cleaned, then you shred it and that becomes flakes. And then you pelletize them. We are aiming to print with flakes very, very soon, and we're developing a new version of our extruder for that.
Are there things that designers can do to make the 3D printing easier? You know, if it's cleaner models, or I don't know, what other things can designers do to make the 3D printing process easier?
It's a very good question, which I probably can't answer in a simple sentence. I think there is a lot of opportunities, but also a lot of constraints in 3D printing, especially in large scale FDM printing, right? So the very first thing that designers should do to make more efficient models is to be flexible and be willing to have a conversation about optimizing the design, or even better, to design from and for 3D printing, right? 3D printing, at least at this scale, is not the ultimate tool for printing any shape in the world, right? So you have a maximum of, like 30 to 45 overhangs. When you trim, you print that thick that then when you trim the plastic, if you want to like print one layer here, but then trim it and then start somewhere else, then that becomes very dirty and it needs a lot of post-processing, which is something you don't want to do. That's why we design objects. If you look at like most of the designs we have, they can be sliced in continuous curves, right? So they are not stopping and like pausing and continuing somewhere else. They don't have what we call traveling, right? Which is like stop, pouring material, and then move the robot, put it somewhere else. We do it sometimes, but as I said, the result is not great. So we can only apply it to specific objects. So and like this, there are many other constraints. I think it's just really important. And you see that coming when you receive a message from a designer or an office, and if the message is, "Hey, find attach an STL. I want to print it. Can you please send an estimate?" That project is never gonna work, right? So it actually never did. So the collaborations that work great are those where there's a designer or someone interested in developing a project and you say, "Hey, I have this idea, or I have this client, or I would love to work with you guys. Why don't we set up a call and we run through these ideas and you guys tell me what you're up to and how you work."
So it sounds like partnering with you is really a key thing that designers can do.
Yeah, yeah, absolutely. We like that's actually, I would say, almost the only format that we do. Also, I mean, Nagami is not only is actually not a manufacturing service at all. It's a design brand that manufactures through large scale 3D printing, and that's our own technology, right? We are obviously open and more than pleased to take designs from others, as we do, but it's always a collaboration, and that's also what makes the project magical, the experience magical, and the overall quality of the product you achieve magical as well, right? So yeah, collaborations, definitely.
Well, I know it's been a while since you got into the world of 3D printing, but how would you recommend beginners start to learn about 3D printing and how they can really dive in to start producing some 3D printed models or furniture?
Interesting. I think, well, the very first time I just got my hands in a 3D printer, I was actually not even in a 3D printer, like in a 3D printed object. I was freaking out, right? It's like, what? how can this be? I mean, that was obviously in the early days. There was only one company in Spain that would offer 3D printing services, and it wasn't really straightforward at all, right? So I think now everyone knows 3D printing, right? Like there are millions of people with 3D printers at their home. I think there's a really good first step to get familiar with the process. But what I would encourage those who actually want to go deeper and want to create large objects and not just, small prototypes and household items and toys, right? But want to actually push their ideas in a real market. I think it's just that challenge. First, try to understand what you have in hands, right? If you have a 3D printer, try to understand how it works, and then challenge it and see, well, how can I optimize it? I know people, for example, one of my employees. I mean, my right hand. This guy he's just amazing, and he bought an Ender machine that is 200 euros, and then he wrote his own rapid code and started printing thicker with it, and it almost looks like a mini version of Nagami, right? So play with it, be creative, and question how the machine works, and question how you design for it before going to a larger scale.
That's good, especially for people like me that are not like you, Blake. You're an expert in it. So for our next question, for projects that get messed up or damaged in the printing process, does that material get recycled at Nagami, or is it something that you just kind of have to throw it out and start from scratch?
Yeah, well, we're trying to reduce the number of projects that get messed up, and also the number of failing prototypes. Of course there are, and yeah, so we keep them, then we shred them, and right now we don't have a shredding machine at home. I mean, at home, like in our facilities. So we send it to another company to recycle. Yeah, but we have also even just shred the material outside and then put it back in the machine, not even pelletizing it, and extrude with it. We haven't really achieved, the product scale, because after a while the extruder gets blocked. But it's a good step, and I think very soon we can actually just take any waste that we produce and immediately after just throw it back in, which will be an amazing step for us and also for 3D printing technology as a whole. I think that's what we should all aim for.
Do you always prototype at full scale, or what's the process that you follow to progress from an idea to a chair, a light, furniture, etc.?
Yeah, mostly yes. We prototype at full scale. It's just more useful. There are so many things that you don't see when you're doing a scale model, and to be honest, our technology has a limit in how small it can go. Right? We have actually tweaked some 3D printing machines to behave almost like a Nagami printer, but it's still not a robot. It doesn't have so many axes, so it's not the same movement. Most of the objects that we do, we can't prototype in there. Sometimes we do half-scale models, especially for tables and so on. But when we do a facade panel, or when we do a chair, it's just much the prototype becomes much more useful for us if we go full scale first. And so we select the areas that we are slightly uncomfortable with in an object, or that can be more problematic, and we print those at full scale before throwing the large print to the robot and wait for, I don't know, maybe 48 hours or 50 hours for it to finish, if it's a very tall piece, like 3.5 meters or so, and expecting that everything worked all right, no? So it's good to just get a few parts first, so you cry a little bit less you know, in your everyday life. Yeah.
So are there any materials that you would like to print more with in the future that you don't typically use now?
Yes, definitely. Well, first, the world of polymers is incredible. There are so many. I mean, there are polymers that weight, feel, and look like metal. Is insane. Or, you know, there's like recycled material mixed with coffee grains that we've used, or with cork, with carbon fiber, with fiberglass, with. So I do think there is a lot to explore in polymers to also kind of respond to different circumstances and different applications. But then, I mean, outside that, when the company grows, which is happening already, we are hoping to also expand to other materials like metal. Maybe we've done some concrete, but it's really not in our pathway right now, and that's also because of questions of on sustainability. But yeah, like combinations between polymers and metal is definitely something in our roadmap.
Well, you know, along that roadmap, you're already doing things that are so innovative. What's next for you? Like, what would you like to accomplish in the next 5 years? Is there this ghost project out there that you've always wanted to do that you haven't done? Do you want to print something and put it on the moon? Like, what's next?
Yeah, definitely not print something and put it on the moon, so I don't have to do a site visit.
Fair enough.
Just in case I can't come back, you know, like my life here. I mean, I'm an architect. Actually, the three partners are architects, and I think you can actually notice that as well in the evolution of the company, in how we're, you know, how it started from the scale of furniture. Well, like every architect does, no? Like every seminar architect has a seminar chair, and most seminar chairs are made by architects, right? So it's an object where you test your ideas because it does have structural requirements, right? Like, you know, it has the weight of a person to support. So it's almost like a mini building. We started with chairs, but aiming to then go to larger sculptures, columns, like architectural elements, interiors, facades. But what we are really dreaming about is a full 3D printed building out of plastic, right? There was actually, like in the 60s and 70s, no, we started really dreaming about an architecture made out of plastics, right? There was the examples of the Futura house and the Smithsons, and, you know, like architecture, the plastic architecture was actually bringing completely new typologies, completely new features, new textures, new effects, new interiors, new everything, right? And we stopped doing that because all of a sudden in the 90s, right, it got public that the plastic was actually incredibly bad for the planet, right? And we were destroying the planet, which we keep doing it anyway, right? Today, plastic has changed, right? Like there's so much plastic that we've accumulated since then that we have to do something with it. I do think that if that plastic starts to open up a new venues in architecture and design, and mainly right in the construction industry, we will first of all speed up the process of cleaning our landfill and oceans, right? Because we are gonna scale up our demand, like the demand for recycled plastic. And I think the right kind of typology for it is housing, right? And so I would love to 3D print houses very soon. And I mean, I would say very soon, but we already have a project that we're prototyping. But it's going to be quite a long-term process that keeps me incredibly fascinated about every single one of the steps.
I love that. I'm really curious about it. I can't wait to hear more.
Yeah.
I'll show you next year.
Yeah, awesome.
Can you share any more about that project you're working on? The 3D printing
The housing
house?
project.
Yes.
Yeah. So, well, essentially is well based on a few very well-known advantages of 3D printing. One is distributed manufacturing, right? Like we can, rather than having to get materials from here, from there, shipping there, pre-assemble there, then shipping again. I mean, architecture, I mean, the construction is a huge mess. So it is. I mean, you go to a construction site. I remember this very famous architect called Prada Pool, Spanish, who unfortunately passed away a few years ago. And he was a visionary, and he started doing plastic houses and based on inflatables, because he went with his kid to a building site, and after the entire visit, the kid so he asked the kid, he said, so what do you think? Do you like this? He said, I mean, yeah, it's very interesting, but Dad, why are they destroying the building? It's like, every time we build something, it really looks like a total mess. It looks like we're destroying it, right? So I think through 3D printing, we can just set up the machines on site, or in a factory close by, or even part of the site, to create a more controlled environment, and then just produce the pieces that we need locally. No shipping, no CO2 emissions, and even being built with local waste, right? So I think that's one of the huge advantages of 3D printing and what we can have in the construction industry, right? So the other advantage is that we can actually create, our robots don't mind if we put a completely different piece right after another, right? We don't have to repeat the same part over and over and over again, like in the Henry Ford assembly line, right? So we can introduce variability, right? And the world of housing is incredibly interesting because every single person has a different lifestyle, a different way of living, and their spaces are incredibly unique, right? Like, you have your own posters, your own tables, your own furniture. So I think giving the customer the opportunity to customize the actual form of the house and see how they feel in that space and materialize it at the same cost as any other shape, right? Within certain parameters. I think that's something that you can only do through 3D printing, right?
Well, you talk a little bit about sustainability in terms of material. What would be the actual impact of 3D printed products, considering microplastics and fume contamination, et cetera?
What would be the what would be the impact of recycled plastics, you mean?
Well, of microplastics and fume contamination. So this is one of the questions that the audience was asking. I think they're asking, what's the impact of the 3D products?
Yeah, okay. So if you mean when you throw them away as well, right?
I'm sure.
So because yes, I mean you're taking plastic out of the ecosystem, you are transforming it into a product, but at some point you can actually throw that product away again into the ecosystem, no? So you have exactly the same problem. The impact of that plastic will be exactly the same impact as the plastic you took to create that product, right? The thing is, the kind of products that you can do through 3D printing are completely different. Like it's actually not, or at least at this stage, is not meant to be used for disposable products at all, right? Like no one has probably drink out of a disposable 3D printed water bottle, right? Because it's economically not viable. So it might be a problem that we face in the future, but to be honest, if you 3D print some plastic bottles and you transform it into a design chair, it's very rare that chair will end up in the ocean, right?
Yeah.
It will end up being sold, being in storage, right? And some of them will be then sent to recycle because they're too big as well anyway, and then be shred and reuse. So I do think the impact that recycled plastic will have in the ecosystem will be much lower, not because of the plastic itself, but because of the kind of products that are using that demand for recycled plastic, right?
So just out of curiosity on that, does plastic have, and this may be a dumb question, but I'm good at asking dumb questions. Does plastic have something that does it have like a usability life? Let's say you take a plastic water bottle, you turn it to a chair, and then you realize, you know what, I instead want to turn this chair into, part of a house, or like when you go to reuse plastics over and over again, what is their shelf life, or what are you losing each time you reuse it?
Yeah, so it depends on the plastic. We normally use PETG. And that loses 1% of the properties.
Okay.
So what is important in there is actually to know like how many times it's used, so that you can understand what kind of product is more suitable for that quality of plastic. So, for example, you recycle first-time use plastics, which we do a lot, right? Like from medical equipment, which is a very, very good quality PETG, and that is a suitable product for example, chairs or objects that have a structural function, right? When you recycle it again, or maybe you recycle it a few more times, then you can create lamps and vases and things that don't have to support anything, right? So you kind of like lower the structural requirement of the product you create as the quality of that material is actually getting lower.
Okay, got it.
Yeah, that actually kind of answered my next question, but was going to ask if you had experimented with using your 3D prints maybe as in unison with other materials like concrete, maybe making complex formwork using your printers, but then using those to cast concrete in.
Yeah, that's a very good one. Which yes, we've done it, and yes, we're excited to do more. 3D printed plastic formware is actually gaining a lot of value in the industry, and there are actually quite a few companies now, many in the States, using plastic formware for many reasons, right? So you can actually reuse it much more than a formwork, right? It's obviously for a certain kind of geometry. So if you want to make a box, you would rather use conventional wooden furniture, right? But if you want to do the SF MoMA, then, for example, right, it has like similar panels, but slightly different as well, and have a shape that is very, very difficult to build in traditional formwork. Plastic becomes a very viable solution through 3D printing. So it allows you for greater like formal flexibility, and at the same time, it's way more durable than any formwork that can compete with those kind of shapes you can create, right? So yeah, definitely, and it's something that we want to do much more in the future, much more of it.
You probably ought to ask this next question because it's a little out of my expertise level.
So So we typically, with our printers, we print at a resolution that's a fraction of a millimeter. What resolution do you use for your printers?
Yeah, so commonly from 1 millimeter to 10, right? We can push it to 15 or even 20, right? Difficult to control the 20. But also we print at the variable thickness. So our software basically regulates how much material we pour in every single part of the toolpath. So we can go in the same toolpath in the same layer. We can go from 1 millimeter, even half a millimeter, to like 10 millimeters.
What are your thoughts on 3D printed architecture? Like, I know we've talked a little bit about 3D printed buildings, but on 3D printed architecture, both as a designer and as somebody who's really kind of on the manufacturing side of that equation as well.
Yeah, well, that's a question for a whole PhD. So actually, my PhD is about that, but and it's in progress. So I can't solve that question fully yet.
You get 3 minutes. Go.
Yeah, there you go. I wish I would get the PhD done in 3 minutes. So I think, look, 3D printing architecture. When like, of course, we're gonna see 3D printed architecture. We're already seeing 3D printing architectural parts, right? Meaning there's always, I don't know how many World's First 3D printed building we've seen, but I guess probably like around 50, right? And for me, none of them are actually 3D printed buildings. Like, we've seen lots of examples of 3D printing walls and then adding a traditional roof on top, right? And then you need to add doors and windows, and for that you don't 3D print those, right? Like you leave a hole and then you put it in, right? So you know, if you want to be in the most kind of radical sense of the word, right? Like, 3D printing is not effectively used in the 100% of the building in any of the examples we've seen. There will be a time when we have multi-material 3D printing and at an insane resolution, so that we can actually see a building fully emerging, like a building like fully printed. It's you know, it prints like the windows and the glass and the steel and then the concrete and everything together, layer by layer, or maybe in a different manner, right? That hasn't happened yet. So that being said, I think the efforts that many of us are doing to really rethink the core of architecture through 3D printing, like, how do you integrate like mechanisms? How is a 3D printed door? Like, that's a question we had to ask ourselves in like some of our projects, right? Like, I mean, we printed a door, and then we printed a sliding door, and then we printed a toilet. Like, how do you integrate, you know, different parts that you currently can't 3D print, right? How do you integrate them in the process of printing? And that becomes extremely exciting. And then you also have to be, you know, flexible and not like so much of a purist at this stage, because, as I said, you know, you can't really fully 3D print a building, and you need to realize that some parts are just not worth to be printed. So, you know, that's why I've got that question like so many times. It's like, well, but why didn't you like print the toilet? It's like, well, because then you print the toilet, but then you need to coat it so that, you know, it's like easy to clean and so on. So, I mean, we printed a cage for the toilet, but then it costs exactly like €3 to throw this thing in it. So it's really not worth it. When it's not worth it, why to do it? There might be a time when it becomes worth it, and we will see it as the technology evolves. But just acknowledge, you know, like pick your battles, right? Acknowledge the parts that are not probably gonna get better through your hard work and your days and nights of pain trying to program a robot to do something that is extremely absurd to do. You know.
Yeah.
Yeah.
All right, I think this is our last question. Blake, you got it?
Sure. How do you maintain your love of craft and design in a highly technical process?
That's a good question.
That is actually a very good question. But I do have a very good answer. It's like I don't have to. Just because I mean I'm lucky enough to have two amazing partners and an incredible team. We're 15 people now in Nagami, so it's still a small company. We're growing quite fast, and we're doubling in the coming months. But they are the ones that are dealing with the technology every day, right? I know a little bit of technology, but I'm much more of a designer and if so, a computer programmer. But I think that like being able to rely on these two amazingly professional people who can pay attention to every detail and who can spend hours and hours and hours identifying which pipe is blocked at this stage of the extrusion process. I can't do it, and maybe because I can't do it and I don't do it, then I have time to keep kind of the overall ideas of the company, identify the opportunities and design with them, right? If I would like get like thrown into the purely technical process, I would probably don't have a space, like mental space for doing what I'm best at.
Well, I hope you continue to do what you're best at because you're doing an incredible job. We have like, I don't know, 8 or 10 more questions, but we are now at midnight, so I promise I will let you go and sleep. Maybe we'll do a follow-up episode where we can get the rest of those answered. But thank you so much for jumping on with us. Blake, thank you for being here. Thank everybody that's watching, and we can't wait to see you again next time.
Thank you so much. Next time I'll come with a house, yeah?
Okay.